Have you ever heard of anything called the theory of relativity? This is a scientific theory that attempts to explain how gravity and motion can have an effect on the passage of time. Time dilation is going to be our topic of discussion today, which is easily one of the most intriguing parts of relativity. Let's start with motion as a foundation for our discussion of time dilation. Imagine that you are riding in a rocket ship that is hurtling across space at an astoundingly rapid rate. From where you are sitting, it looks as though time is going regularly. Yet from the perspective of someone on the ground, time seems to pass more slowly on board your rocket ship. This is due to a phenomena known as time dilation, which states that time seems to flow at a slower pace in a frame of reference that is moving relative to an observer. The reason for this is that moving frames of reference cause time to appear to move slower. Gravity is another factor that might cause a slowing down of time. Time seems to move more slowly the closer you are to a really big object, such as a black hole. In point of fact, if you were to approach a black hole from a sufficient distance, it would seem as though time had completely stopped. This may come off as science fiction, yet it is something that has been demonstrated via several trials. For instance, because GPS satellites are located at a greater distance from the gravitational pull of Earth than clocks on the ground, the atomic clocks on the GPS satellites run at a somewhat quicker rate. Time dilation is an essential component of Albert Einstein's general theory of relativity, and it plays a significant role in our overall comprehension of the cosmos. Here is another example of time dilation. Imagine you are standing at the base of a mountain, looking up at the peak. At the top of the mountain, time is moving slightly faster than it is at the base. This is because the force of gravity is slightly weaker at the top of the mountain, which causes time to move faster. This effect is very small and not noticeable in everyday life, but it has been measured with very precise atomic clocks. For example, if you were to place two atomic clocks at different heights on a tall building, the clock at the higher elevation would tick slightly faster than the one at the lower elevation, due to the difference in gravitational force. So, time dilation is a fascinating concept that can be observed in various ways in our universe. Whether it's the difference in time due to motion or the effects of gravity, time dilation is an essential component of Einstein's theory of relativity. Understanding time dilation can help us better comprehend the mysteries of our universe and the fundamental nature of time itself. Thank you for watching, and I hope this explanation has helped you understand the concept of time dilation a bit better. If you have any questions or comments, please feel free to leave them below.